Mechanisms. We are now ready to formalize the notion of a general non-direct revelation mechanism. The idea is that each player has some private information, little ti in capital T, that captures his preferences over a set of alternatives A, i.e. Vi of TIA is the value that player I assigns to A when his private information is Ti. We wish to implement some social choice function f, which is maps from the domain of the capital T1 multiplied by capital T2 and so on until multiplied by capital T8 Tn to the range A that aggregates these preferences. We design a mechanism for this purpose. This will be some protocol for interaction with the players, specifying what each can say and what is done in each case. Formally, we can specify a set of possible actions xi for each player and outcome function A, which maps from the product of x1, x2, x3 until xn to the range A that chooses an alternative in A for each profile of actions, and payment functions P, which maps from the product of x1, x2 until xn to the range R that specify the payment of each player for every profile of actions. Now the players are put in a game with strict incomplete information, and we may expect them to reach an equilibrium point if such exists. Definition 9.24. The mechanism for n players is given by A players type spaces T1, T2, T3 until Tn. B players action spaces x1, x2, x3 until xn. C an alternative set A. D players valuations functions Vi, which maps from the product of Ti and A to R. E an outcome function A, which is maps from the product of x1, x2, x3 until xn to the range A. And F payment functions P1, P2, P3 until Pn, where Pi is where Pi maps from the product of x1, x2, x3 until xn to the range R. The game with strict incomplete information induced by the mechanism is given by using the types spaces Ti, the action spaces Xi, and the utility Ui of Ti x1, x2, x3 until xn equals to Vi of Ti A of x1, x2, x3 until xn minus Pi of x1, x2, x3 until xn. The mechanism implements a social choice function f, which maps from the product of T1, T2, T3 until Tn to the range A in dominant strategies if for some dominant strategy equilibrium S1, S2, S3 until Sn of the induced game, where Si, which is mapped from Ti to the range Xi. We have that for all T1, T2, T3, Tn, f of T1, T2, T3 until Tn equals to A of S1 of T1, S2 of T2, and so on until Sn of Tn. Similarly, we say that the mechanism implements f in an x-post equilibrium if for some x-post equilibrium S1, S2, S3 until Sn of the induced game, we have that for all T1, T2, T3 until Tn, f of T1, T2, T3 until Tn equals to A of S1 of T1, S2 of T2, and so on until Sn of Tn. Clearly, every dominant strategy implementation is also an ex-post Nash implementation. Note that our definition only requires that for some equilibrium, f of T1, T2, T3 until Tn equals to A of S1 of T1, S2 of T2, and so on until Sn of Tn, and allows other equilibria to exist. A stronger requirement would be that all equilibria have this property, or stronger still, that only a unique equilibrium point exists.